Good afternoon. Okay, I want a quick show of hands. Who of you is a developer? Who of you is using containers? Who of you have never heard of containers? Good, you're in the right spot because we need to answer one question first. What the heck is a container? Who can help me with that? And no, I know that Simon is here, is still here in the room. He talked about containers in the C4 model. It's not what I mean. But he said something like it has the word containing. It contains something. A container is a receptacle for holding goods or whatsoever. And how we use containers, we look at containers in the way how we look at containers in the real world. So say, what is a container in the real world? It can be anything from this, a soda can or a beer can, to this, your airtight container to contain your food and store it. Or what we see in all the Docker images is like, let's make a shipping container because bigger is better. If we look at these containers, it has a particular thing. It's basically a border between whatever is inside to protect it towards the outward world. I mean, your soda can is there to preserve the flavors, to preserve the carbonation. The airtight container is there to make sure there's no oxygen getting in, so your food is getting good. And your shipping container obviously is there so it doesn't fall off the ship. Makes sense, right? The thing is, it makes sense to pick the right container. I tried putting beer in an airtight container. That might work, but in a shipping container doesn't make sense. And that is all logical, right? However, a lot of people think of containers in this way of describing. Also, if we talk about software containers. So let's take our Java application and put that in a container. Ah, poor JUG, it's airtight. However, well, we want to make sure that JUG is still alive. And we want to make sure that your Java application is actually doing something. So it's not just a boundary with the outside world. No, actually, it's a container with holes in it because we need to have interaction with the outside world. Unless you don't, but I think your Java application needs to have a connection with a database. Maybe a user might make sense. So that needs to flow information in and out. Still, we think of containers as these boundaries between the outside world and your application. And people have this belief that if I have an application and I put it in a container, then by default I am more secure than before. Guess what? That is not true. And that's what we're going to talk about today. Oh yeah, this is the most boring slide ever. It's me. I'm a staff developer advocate. People ask me, what the hell is that? Well, ask 10 developer advocates what developer advocacy is. You probably get 54 answers. I would describe myself as I used to be an engineer and now I email. Let's keep it to that. I'm a Java JUG leader, Java champion, blah, 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 blah. Not important. I work for a company called Snyk. Probably you've heard of that. We do something with security. So that is the context of my talk today. And why? Let's look at Docker containers to simplify it. And I know there are many other things, but Docker is still the de facto standard. And the reason for that is the amount of downloads weekly of Docker containers from Docker Hub or Docker images from Docker Hub. So let's talk Docker containers. Let's simplify this talk into 5 tips not to fail your security. And hopefully if you have one of them, you're like, hey, I need to look at that. I'm already happy. I'm already a winner in this case. Hopefully all 5 of them, you're like, I'm already doing that. Hey, 100 points again because you're on the right step. Obviously I have more tips, but let's keep it to 5 because it's already Thursday. So if we want to create a Docker container for a Java application, the first and most important thing is choose the right Docker base image. Because what does a Docker file start with? What is the first line of a Docker container or of a Docker file? Exactly, something from. And let's put something like from Ubuntu, because why not? It contains everything and probably it works. It works on my machine. Let's ship it into production and gone. The thing is, do we need full Ubuntu for my tiny microservice? Probably not. And 2019, late 2019, I did a small research on Docker containers and their vulnerabilities. And basically, we downloaded the 10 most commonly used Docker images from Docker Hub that were used as base images and scanned them for vulnerabilities. This was the result. My manager is a Node.js developer, which was fun at that point. Which probably is the case why I'm still not promoted, but okay, never mind. Thing is, all these Docker images were vulnerable. And of course, I can make a lot of jokes about Node.js now, but the thing is, at that point, it was not the Node image that was the problem. No, these were just the latest images that I pulled from Docker Hub. Like you see in many Docker files, I just put a tag in and simply take the latest, which can be okay in some use cases. Only the latest Node image was based on, at that point, a somewhat outdated Debian distribution. Well, most Node applications don't do a lot, so do you need full Debian is the first question. And if we looked at the 560-something vulnerabilities in that Node container, most of them would be traced back to actually the Debian layer, because it brings in a ton of binaries. Then you need, again, like probably you will not hit these binaries directly. But if you think about it, they can be part of a chain of attacks. If for some way you can get in that application, you can use all these tools that are in there to craft a nice, problematic, booming problem for the whole network. We see that if you use a base image, and you pick a base image, that it makes a lot of sense where this base image is based on. Because we're basing it on an image from Docker Hub or any other repository, but that most of the time is based on something else as well. So it already makes a lot of sense if something is based on Debian or Debian Slim or Ubuntu or maybe Alpine if that makes sense for your application. Well, I did some research on JDK 17 this morning on the Eclipse Xamarin JDK images, and you see that it makes a lot of sense to pick the right one. The default is based on Ubuntu 22 and has 35 vulnerabilities at this point, at least this morning. Maybe somebody solved the one or somebody found one. But if you base it on the CentOS 7 distribution, you will get approximately 1,200 more, which is fun if you're keeping score, but probably not what your boss wants. In some cases, it makes sense to go for the Alpine version because it's a smaller version if you don't need to use libc or something. So picking the right image and picking the right tag and knowing what this tag or this image consists of is crucial not only for making your image smaller, but also for potential risks in your application. Because nowadays, the Docker file is part of your repository. So if something goes wrong, they probably come back to your team to fix it. Okay. What could possibly go wrong with an image, right? Well, most images come into your system with a lot of binaries and a lot of tools, and sometimes programs even use these tools. For instance, this one is a very old one. Who has heard of ImageMagick? It's a package that is delivered with a Debian distribution, and well, this is a very old Debian distribution, and the fun thing was you could do a lot of silly things with it, and it could end up in problematic situations. That's why I called it image tragic at that point. I have a demo here, and what we can do, it's a simple Node.js container, and we made a small website around it, and it's running here locally. What it can do, I can choose a simple picture, and let's take a picture from. Oh, that's a very old one. Let's pick this one, and it uses ImageMagick under the hood to resize my picture to a certain size that is suitable for, it says Twitter, I probably have to rename it to X or Y or Z, who knows what it's called next day. Anyway, that works. But this is an outdated version, and well, hey, it works, right? There are no vulnerabilities in my application. Why, in God's name, should I rebuild this image? Well, because this image uses another binary to do the scaling for me. What if my image looked something like this? Let me see if I'm in the right folder. Okay, let's look at rce1.jpg. It turned out that image Oh, RCE1, Brian, come on. Typing is not that hard. RCE1 is a description of a JPEG, similar to what you see with descriptions for SVGs. And for some reason, ImageMagick does accept this. But it doesn't do proper input validation. So actually what we're saying here, we want to fill the view box with a JPEG from a certain URL, but we can pipe it with an OR and then say touch RCE1. So basically creating a file. Let's see if that works. I mean, I am here in this application, and let's see for now, RCE1, the file does not yet exist. But if I put this file here, let's do this again, pick RCE1, open it and resize it, we see that we have no image back. Okay, cool. But let's see what's now in the Docker container. And we see that RCE1 is now a file that is created. So I just created myself an arbitrary code execution, which means if I can create a file, I can create a file with content. I can come back tomorrow, hit that content, which it may or may not be a script, and do all sorts of things in your Docker container. Maybe spin it off, spin it down, spin my Bitcoin miner off, or even worse, create a reverse shell attack. Because now I have capabilities of throwing code in your application. Trick question, what is the default user for a Docker file or for a Docker image? Hold that thought. So thing is, if you're not specifying something specific, you have all the freedom in the world to do this. And this is because I am using an outdated Node.js image. If I update that image to a newer one and not do anything on this program, problem solved. All right, let's move on. Only use what you need, and that sounds silly because we already have a base image, right? But if you look on the internet and you ask the question, and hopefully ChatGPT does a better job nowadays, but how do I create a Docker image for my Spring Boot application? There are still these websites and these tutorials that end up with something like this. What is wrong with this Docker file? The answer is everything. Because let's figure out what am I doing? My image is an image that contains full OpenJDK 17. I don't know from which vendor, but it's full OpenJDK 17 and Maven Streamlit in it, Maven 3. Cool. I copy all my source code in that image, and then I use Maven with the, probably it's at Spring Boot run, so it has the Spring Boot dependency or the Spring Boot starter dependency in it to start it up. That means I have the JDK, the full JDK, my source code, a build tool, and all I actually need is the artifact it builds. We still see in many corporations, we still things like this because, hey, works on my machine, ship it, because we need to be on time. This image is about 1.03 gigabyte, and what it does is nothing more than 4 lines of code that says "Hello world" if I hit that endpoint. Good use of memory in this case. But what can we do about this? Well, first of all, if you want to build your image in a Docker file or build your application in a Docker file, that's totally fine. But there is something as multi-stage builds in Docker. Your build image doesn't need to be the image that goes to production. You can distinguish between a build image and a production image, or even more steps if you want to. So if we move this step over, I'm saying, okay, let's still use the Maven 3 OpenJDK 17, copy my source code and build it, but the only thing I actually need from that is the artifact it creates. Correct? Next thing what I need, and we used to do that all the time when we're all working on WebSphere or something like that, or some other physical system, you only need a Java runtime. So a JRE might be useful for this. So I'm now using a Eclipse Tamarind 17 JRE based on the Alpine image. I only copy over the jar file, and I basically say java -jar, and then call the jar file that I'm copying. Good thing is that whatever I do in the first steps is getting thrown away. It's not visible anymore, and I only end up with a smaller image that's now based on my Spring Boot image that is still way too large, but a smaller image based on Xamarin 17. At this point, I only have 270 megabytes instead of the 1.03 gigabytes. Upside of this as well, what I said, like the first step is only used for building, and then we refer to that. Say I need to put credentials in there, and now I do it as parameters on the command line. But say I need to streamline credentials in that to hit a certain API or to hit a certain repository. It is not traceable again in my second step because the first step is thrown away. So that means if I need to put credentials in there in the first step, it's fine. It's no worries. You can do everything you want, but you only end up with the last stage of this build. But okay, then people will probably say, JRE, what is that? Well, it used to be back in the days when Java was still old and clunky, we used to have the JVM, or we would have Java, which contained on one hand the JDK, the Java Development Kit, and on the other hand the JRE, the Java Runtime Environment. But Java 17, does that still have a runtime environment? Well, since Java 9, we have modules, correct? Who uses modules? Exactly, 2 people. Great. What we can do with these modules is amazing because we can now create our own Java. And you might think like, why should I do that? Well, you can slim your image in your Docker container to the exact size that you need. So nowadays with Java, a JRE is not supplied anymore. However, some vendors or some creators of Docker images, like in this case Eclipse Xamarin, still create a one-size-fits-all JRE for you that you can use. However, that might still be too big, or you want something else in it. So let's use, in this case, JLink to create a Java that is specifically useful for my Spring Boot application. So I can use JLink. But what I need for JLink is to know what kind of modules I have to put into my system. Well, you see, I have the modules that I want here by Googling on the internet, like, okay, what modules do I need for Spring Boot? That was clunky. And this might work if you say, like, okay, I want to create an image that is suitable for my whole company. Let's put this in, and everybody use the same image. Might be possible, but it's still, it might be too much. Maybe I'm not even using something like Java XML crypto or whatever is there. So how do I get the models out of my application? Well, luckily there's a second tool called JDeps. I can call JDeps with a bunch of parameters in this case to print out all the modules for me. I point it to a directory where I have my dependencies, and I point it to my jar file, and then it will come up with a list of modules that I can use to feed that into JLink. Okay, but then you have the problem, how do I do that in a Docker file? Well, a Docker file gets a bit big and clunky, but it's useful. Well, let's step through it. The first part we know. So let's focus on my jar, my application. In this case, I chose for the fact to do this after the fact, as in my jar is already there. It's a fat jar because it's a Spring Boot jar, and I need to know what dependencies are there. Dependencies are packed in. So what I did was, the easy way out was to unpack it. One of the things you can do. There are other solutions, come back to that later. But I unpacked it. So I know if I unpack, unzip basically that jar, I know that all my dependencies will end up in bootinf/lib. So that's where I point the class path to, and I point the target to my jar file. The outcome of the modules are now in the deps.info file, or I write them to a temporary file. And then in the next step, I ask JLink to look into that deps.info file and create myself a particular Java version with no manual pages and no header files, and it does support compression, and store that, and this is still my first stage of my build, in /my JRE. Then in my second stage, in this case I base my image on Debian Bookworm, on the Slim version, because apparently the Alpine version do not work on ARM machines, but okay, nevertheless. I chose an image, and you need to choose the image that is suitable for you. I basically installed the JDK that I created, set some environment variables, copy over the jar file, and then we're done. Then I have a specific jar file, or I have a specific Java suitable for my application. So what is the upside for that? Well, the whole thing looks pretty much like this. What is the upside of this? Well, you know that everything that is technically in the class path for Java can be loaded into memory. So even modules that you're normally not using can be part of an attack if you're calling, for instance, deserialization chains. I can use these objects and chain all these things together to create a deserialization chain, and then in the end use that for an arbitrary code execution. If you want to know more about that, I did a talk last year on deserialization chains and how that works. But everything that is not there cannot harm you. So make it slimmer from a security perspective. But also, if it's smaller, it's easier to start up, it's easier to transport, and it's easier to scale in a larger system. I now did the clunky thing of unpacking my jar. But obviously, if you're using a Maven project, and I'm a Maven guy, you can also use the Maven plugin, dependency plugin, to copy all the dependencies that you're using for building that application into a specific folder and point to that when you're pointing JDEPs to your dependencies. And normally I would advise to do it like this. Build it with Maven and point your Docker file or point your JDEPs part of your Docker file to the /dependencies the folder that is now part of your target directory. If you want to know more about that, I wrote a full workthrough on a blog post, and just experiment with that if that works or not. It also gives you the freedom that if you do that and you need something else in it, why not add that in? But do that purposeful, as in, if you actually need that, like, I don't know, something to trace whatever is in memory or some tooling, yes, you might need that, but only put it in when you actually know that you're going to need that, and not just put everything in by default. Who knows what the least privileged principle is? All right, thanks, I appreciate that. It's basically saying, like, as a user or as an actor, you can only do what you need to do and nothing more. Think about it this way. Say, I'm in a hospital, which hopefully does not happen a lot, and I have something. I don't want the whole hospital to know it, only the doctor that's treating me, because it's nobody's business what I did wrong, and I drank too much last night, right? So let's just make sure that the people who need the privileges only have that, and not anymore. Well, we already looked at the file and the multi-stage build. Let's keep it for simplification. Let's use this one. I already asked you, what is the default user in my Docker image in my last stage? Unfortunately, it is root for Docker. Luckily, other systems don't have root by default, and I know that if you want to deploy this on OpenShift, OpenShift will probably scream at you and throw tomatoes at you because you're not allowed to do that with elevated privileges. But what you should do is make sure that you create a specific user. So let's focus on the second part of my Docker file and say, like, hey, let's add an extra user. These are the important lines. In this case, it's an Alpine-based image, so it can be a little bit different if you're on an Ubuntu-based or whatever image. But what I'm creating is a specific user without shell access, etc. I give it, in this case, ownership over the project folder because that's what I need. And then the last yellow line, I call that user. That is the most important one. If you don't call that user, then you're still root. You just created a user and done. The other thing you need to think about is if you're using a base image that already has a lesser privileged user, then you still need to call it. I know many of the Node.js images do have users streamed in with these images that are not root, but if you don't call them, you're still running as root. So you actually need to call them, and from that point on, all the stuff that you do is now based on this user. So if I'm in that container, I don't have the privileges to actually do or touch other things as easily as possible. I then have to do some tricks to elevate my privileges before I can actually go and do you harm. Scan your images and Java applications during development. Well, if you're developing something, I know we are builders and not breakers. So you probably look at your Kanban board or your Scrum board, and you have like these tasks from your product managers that like, hey, if I click on this, it needs to do that. And you're like, that's easy. Hopefully you write a unit test around it or not. I mean, we have 3 billion users in production that can test for me. It's all fine. So somebody recognizes that thing, right? Yeah. Hey, come on. They will ping me if something goes wrong, right? It's the easiest way out. I mean, we have to reduce our budget nowadays. But it is good. It's a good practice to already scan your stuff because you maybe have missed something. In our research, the open source security report that we do once in a while, we asked people like, when do you scan your Docker images for operating system vulnerabilities? 50% said we don't. Okay. Well, it is not that hard. And obviously, I work for a company that does tooling. It's 2 lines of code. I install a CLI, and if I have that, I pull the image, and I say, in this case, Snyk container test, and then point it to the image. Obviously, there are also other ways to do this, or other vendors that can do this, but it's easy to do this and to make sure that it's part of your pipeline. So if I do this, it comes up with something like this, and it says, hey, in this case, you have 18 issues, somewhere here in the lower part. Okay, then I can look through the issues and see, like, are they actually important? Do I need to do something about it? But at least you know, and you can make an informed decision before you say, like, hey, it works, drop it. Unfortunately, that still happens. But this is the base image. It's even more important to do that for your own image than what that you created. Say you created an image based on a base image, or based maybe on something else, and you put binaries in and that kind of stuff. If I do this in my CI pipeline and say, hey, container test, this is my image with the tag, and this is also the Docker file, it can provide you with information to say, like, maybe you should update to a newer version of the base image because it has less vulnerabilities. But next to that, you can test it in production, or you can test it in development. But when it's done and you ship it to production, you might not touch it anymore because nobody's touching the machinery and nobody's touching the application anymore. So you probably do not rebuild your Docker container anymore. However, you still need to monitor it because something might be okay now, but might be vulnerable tomorrow because somebody found a loophole. So with monitoring that, you basically take that static part of what is the image, put that on a system, and make sure that it's getting scanned every day, every week, or whatsoever, and you get actively pinged when something is wrong, or when there's a new solution for a problem that already exists. That is proactive instead of it's reactive, but at least you know and you can take responsibility according to actual information instead of guessing. So let's go into an application with a problem in a Docker container. Well, you see an application here, and this is an old application. This is an old application based on Apache struts. I will come back to that later. Why? Because we still lift and shift, right? There's an old application. Let's Dockerize this because now we're modern. Put it in a container, put Java 21 on it, and it works. Well, not with this one. The thing is, it runs in a Docker container. Let me show you what the Docker file for that one is. I think I have it somewhere. Somewhere over here. This is the Docker file that I used to create the application. So a multi-stage build, Maven 3, JDK 8 in this case. I built the stuff, I copy some things, and in the second stage I'm using a Tomcat server because that is needed for this application. Tomcat 8.5.21. What is wrong with this application, or with this Docker file? Who paid attention? Tomcat is insanely old. Yeah, true. But what is more wrong with the application? You didn't call a user. Thank you. I have stickers. You get a sticker. Yes, I love you too. Anyway, I didn't call a specific user. But Tomcat 8.5.21 is old, insanely old. The problem with Tomcat 8.5.21 is that 8.5.21 has a problem in it. And the problem is this, an arbitrary code execution. So it doesn't matter what my Java application does. The Tomcat container has an issue. The issue is that it was possible to upload a JSP file, as you can see here, via a specially crafted request. This JSP file could then be requested, and any code it contained would be executed. Well, let's do that. I mean, let's go to my favorite database, the exploit database. And there's an exploit created for me already, so I don't have to do anything. I don't have to ask ChatGPT. No, it's just there. It's a Python script. Well, you see, Python is used for great purposes. What this Python script does, it creates that specially crafted request, and it does two things. The first thing it does, it creates a payload with only this. Just a println with all A's in it to see if it actually executes. Okay? If that works, and we see that the thing is vulnerable, we do the actual attack. And the actual attack is creating a JSP file with a form. And that form contains a text box and a submit button. And every time I hit submit, everything that was in the text box goes into a runtime.getRuntime, and I execute that. And then I have the input stream reader connected to output so that I can actually read what's going on. Basically creating myself a web shell. And again, we already know that I have root privileges. So let's go. This thing does not exist, just for purposes that this is an actual demo. And I'm not faking it. I loaded the thing over here. So let's do check. And check is the first thing, and it says, cool, it's vulnerable. Okay, let's figure out if that is actually true. So poc.jsp now contains all A's. I'm not touching the application whatsoever. So let's do the second step. Let's go back again and now do pwn, uploading web shell. Let's see if it's already there. And ta-da! I'm root. And I can do all sorts of things like spinning up things, throwing things away, and you don't even matter. But you don't even mind because that application is still running. That application is still up and running over here and doesn't do anything. But in the meantime, I'm in through a web shell because you're using an outdated version of a Tomcat container. Because hey, we didn't touch the application, right? Why should we rebuild it? You could have known if you would scan it on forehand. I scanned it, and I did it before the talk because you were all leeching the Wi-Fi, obviously. And what I see here is that my scanner says, hey, you're using 8.5.21, which has over 735 vulnerabilities. 70 of them are critical. You could do an update to a newer version, to a newer minor version, to the 92 fix, and it only comes up with 35 vulnerabilities, and none of them are critical. If I would do that, rebuild the whole stack, you will see that this is not possible anymore. Just by updating your base image in this case, I already resolved a major incident. On the other hand, this is when I do this on my local machine. It's all great. I mean, I can do this while I'm developing or make this part of my CI pipeline or even call this as a Maven hook or something like that. But what if this thing is already in production? Well, what I can do as well, and I did it over here, I connected my Git repository and it found the Docker file and it says pretty much the same thing. You're using Tomcat 8.5.21 and you could go to a newer version, to a newer minor upgrade to solve a bunch of things, and because it's already updated, it's already connected to, in this case, my GitHub repository, I can create a pull request right away, or even automate that if you want to. But that's all up to you. You can do it in different ways, and you should do it in different ways. Because at the point where we put this into production, it was okay. Not anymore. So you should take care of your Docker images. That's basically what I'm saying. And you should update your images, even though your application doesn't change. But talking about your application, say this is your application. This is the binary. This is the jar file. This is the Spring Boot jar file. How many of that is the code that you wrote? It's this. Pretty much this. Who of you does code reviews? The rest of you does pair programming. It's okay, fine. I'm not judging. But we do that on our own code. How about our things like dependencies and that kind of stuff? Are we looking into that? Do we have some policies on that? Are you actually allowed to pull them directly from the internet? Are you actually updating that? Fun story? Yeah, some of that, great. Hopefully you do that once in a while. You take care of that. I used to work for one of the major banks in the Netherlands, where I'm based currently. I came on a project and I found out that in their POM file there were 4 different XML marshallers. God knows why. And I'm not sure even if all of them were in use, but they were in. That means they're part of the class path and they can be part of an attack. So if we look at problems in your application, they can be an engager to call something that is there in the environment and use that at a larger scale to attack your application. What we see is that the most problems are not in the dependency that you actually pull in right away, but the dependencies that your dependencies depend on, because we know it goes several layers. I pull in a Spring Boot starter, and that comes with a lot of friends, and more friends. And at a certain point you download the internet twice. Just for a funny project, and this was already in 2020, I literally did this on a conference. For a demo, I created a simple application for a Spring Boot scaffolder, basically just one endpoint that says hello world. Lines of code written, 4, and then I decompiled everything, and it turns out that the lines of code in production were over 500,000. And we take good care of our code, but not of the code that we pull in, and that is now part of your application and now part of your container image. So I said this application was written in Apache Struts, and that's for a reason, because Apache Struts is so funny. So I have this one. This one runs on localhost, but I also have one that runs on Heroku, and basically Heroku is just a container that is pinned up if you just run a Java application on it. This application has that problem with Apache Struts. And what it does is Apache Struts 2 had I think it was in 2017, when Equifax got hacked, they used an outdated Apache Struts version. And basically what they can do is, because Apache Struts does a lot of routing and that kind of stuff for you, we could create a request with a special header and then basically do arbitrary code execution. The header looks something like this. And as you can see, this is a content type, right? This is the key, this is the value. Who recognizes this content type? Come on. It's an invalid content type. Really. The thing is, in this specific version of Apache Struts 2, invalid content types, you go to an exceptional flow, and for some reason you are allowed to utilize OGNL. OGNL is the expression language within Apache Struts, and Spring also has an expression language which you can use in the same way. And what happens is you can interfere with objects that are already in memory. But I can also call, in this case, new objects, like a new process builder. Say to the process builder, spin me up a bash, and give it an arbitrary command. So by doing this, I can actually engage with that container, and everything that is there available in my container, I can use for my next part of my attack. So let's see if that works on this. Let's just let's use something easy like the environment variables. That'll be fun. So what I'm doing here, I'm using that header that I showed you, and I'm now substituting and make sure that the word command goes out and the word env goes in, which basically shows me the environment variables. I say curl get HTTP localhost. Well, it's not on localhost, it's obviously on Heroku. So let's copy and paste that, because that's what I'm good at as a developer advocate. And let's see if this actually works. So if I run this, then this comes back. And these are the environment variables of my Heroku pod, which basically is nothing more than a container. I think they're basing their container on build packs. But I now know where the Java home is, I know what the options are, but if I can call the environment variables, I'm probably able to do more. And if I have root access, I can do all sorts of things and grab whatever is there available for me and use that as weapons to kill everything in my environment. So it depends on where you look at. There are different ways to get into a system. Sometimes I'm just going for the application. Sometimes I don't need to touch your application and go, for instance, for the container, because now that's also part of your code base. Well, what can possibly go wrong? I just showed you. Next thing. A lot of people still, and apparently managers by default, think like, if we put in Docker containers, then we're safe. I already told you that. But most applications, if you just lift it and shift it, they're not built to be containerized. So you should think of how to build an application if you want to put it in containers, and especially if you want to build it in a cluster or use something like Kubernetes or something like that. Because if this is my Java application in my container, I probably do not have just one. I probably have 3 or 4 or millions of it because I want to be able to scale, right? Well, that is great, but if I find out, because I have proper logging and proper alerting, that somebody is in one of my containers, over in one of my pods, over in one of my instances, the first thing I want to do right away is boom, making sure that one does not exist, because then the hacker has to start all over again. And hopefully I am able automatically to spin up a new one and make sure that that is the newer version of it. But you should have that preset in your mind before you create the application. So it's not easy to grab an old application and put that in a Docker container. Because in most cases, there are also sort of things as caching, persistent logging, databases. Like, you don't want that in your application. Who uses an H2 database in production? I saw one hand, oh my God. No, but you get me, right? You don't want these persistent things in. You want them out of your container and be able to demolish your container at any given moment. Because there's one thing worse than being down is being hacked and that your data is out in the open. And that's what you not want. So make absolutely sure that your application is built in such a way that you can demolish it at any given time and spin it up with a new one. 44% of Docker image vulnerabilities can be fixed with a newer base image. Who uses in their Docker files the latest? That can be a good solution, but that means if you do that, then you need to rebuild over time, because the latest now is not the latest tomorrow, or the other way around, right? The latest now is a moving target. Some people say, I'm not going into this discussion, but some people say that it's easier to have to use a given tag or a given hash for it, that you always have the same build, so you actually know what's going to happen. But that leaves the burden up to you, that you need to refresh that, rebuild that with a newer image, update that image. But updating your application or updating your Docker container with a newer base image can already fix a bunch of vulnerabilities, and we already saw a problem with that earlier when I showed you the Tomcat problem. If I would use if I was using the latest image and just rebuild every single week or month and automatically throw it to production, it would have been fine. We asked people, like, how do you find out about new vulnerabilities in deployed container? The 45% of the people said we probably won't. And let's go to the next task on our sprint board. Well, the thing is what I said, a lot of people still do this. Ubuntu, latest or whatever, and the latest now is not the latest tomorrow, and specifically if you're pulling in other binaries as well. If you do that, please make sure that if you do that manually or scripted, that you use the --no cache flag for it, and that you absolutely bypass the cache, because we found out for different customers of us that they're still like, oh, we were rebuilding, but they were hitting cache all the time. So not a good thing. All right, let's sum this up. First of all, choose the right base image. Choose the right base image, not too big, not too small. Make sure that that base image fits your needs. Don't say, like, I choose the biggest one, it's great, now everything works. Use only what you need. Do you need the full Java? Do you need your build system in your application? Do you need your source code in your container? Probably a runtime or even a slimmed down Java version that I showed you with by using JLink and JDeps is the minimal thing that you need. Try to take and make your containers as small as possible so they have the least amount of weapons in it that a malicious actor can use. Please do not ever run as root. Always pick a a less privileged user, create a less privileged user, and run your application with that. Scan your apps during development, but also monitor it over time. And create your applications in such a way that they are built to rebuild or built to be destroyed and rebuilt. If you want to know more, these are just 5 tips. We created a 10 best practices cheat sheet with some more things specifically for containerization in Java. If you're interested in that, this is the old version. We already created a new version of it. I will publish the slides, by the way, so don't worry. And that is pretty much everything I had to say for today. Thank you so much. So I have a couple of minutes left. Any questions? Yeah, you fall asleep. I got it. Security. Anyway, if you have questions, feel free to come up or to come to see me out later. I'm still here. Thank you so much. Cheers.